In this video, we are going to be solving proportions. Here is our lesson outline. Part 1, we're going to learn how to identify proportions. Part 2, we're going to solve simple proportions. Part 3, we're going to dive a little deeper and learn about how to solve complex proportions using the butterfly method. Then we're going to learn how to set up these proportions ourselves to solve problems. Then I'm going to show you how to use percents to help you solve problems. And then we're going to use proportions in scales. So the first thing we're going to start off with is identifying proportions. So identifying proportions. So what I'm going to do is I'm going to give you two fractions that look like this. Okay, and I'm going to say, are these proportional? Well, what is this really saying? I'm saying that 2/4 is equal to 6/12. So what am I saying again? I'm saying 2 out of 4 is the same thing as 6 out of 12. How can I prove that? Right? So to make sure that is true, make sure that they're proportional, what I could do is reduce both fractions to see if they are equivalent. Okay, let me try that. All right, so 2/4. I'm going to divide by 2 top and bottom because I'm simplifying. I get 1/2. Okay, and 6/12. 6 out of 12 divided by 6 divided by 6. I get 1/2. They are equal to each other. So that means they are proportional. Okay, 2 out of 4 is the same thing as 6 out of 12. That's what we're proving right now. If I had a number where I said like 5 out of 15 is equal to 6 out of 12, let's just say, well, this can simplify to 1/3 because I can divide by 5 top and bottom. I'm saying 1/3 is equal to 6/12. Well, we said 6/12 was 1/2. 1/3 is not equal to 1/2, so that's not proportional. So right here, this is an example of being not proportional. Not proportional. This is an example of being proportional because they both equal 1/2. 1/2 does equal 1/2. Okay, but what if I need you to find out if two ratios are proportional and there is a missing value? For example, what if I say that 2 out of 4 is the same thing as something out of 12? 2 out of 4 is the same thing. The same thing comes from this equal sign. 2 out of 4 is the same thing as something out of 12. How can we figure that out? That's where the next slide comes in. Well, sorry, that's what we're going to be learning throughout this whole lesson. How to find that missing value. That's the whole point of this whole video. How to find that missing value. But first, we need to make sure we understand what proportions are. So on this slide, I want you to practice what we just did on the last slide. Simplify both fractions and see if you get the same simplified version if they equal. Go ahead, press pause, and then come back to check. All right, welcome back. So 5 out of 15. All right, if I simplify that, divided by 5, I get 1/3. Okay, and 2/3, it's already simplified. These are not equal, so not proportional. All right, let's try the next one. 12 out of 15. Okay, they have a 3 in common. So I can get 4/5. And the next fraction is 4/5. Hey, these are equal. So these are proportional. Okay. Well, one thing before we move on is, yeah, you can simplify both fractions and then compare them in its simplest form. That's what we're doing. This is the simplest form. All right, you can't simplify anymore. This is the simplified form of 12 over 15. So 4/5 equals 4/5. That makes it proportional. That makes it equivalent. But what if you weren't dealing with fractions? Well, you don't have to deal with fractions the whole time. If you really wanted, you can do long division and figure out what the decimal version of each is. And if you do, you will see that that equals 0.80, and so does this one. They equal the same value, so it's still proportional. You don't have to look at the fractions. You can go straight to doing long division for each of these fractions, and you'll get a decimal value, and then you can compare the decimal value, whichever you're more comfortable with. Sometimes it's easier to just simplify the fractions. That's what I do. All right, so we just finished identifying proportions. Now let's try finding a missing value for simple proportions. So part 2, solving simple proportions. If I give you two ratios, these are ratios. These fractions are ratios. A ratio compares one quantity to the other, like 4 to 5, x to 50. If given two ratios and a missing number, here's my missing number, you will need to find the missing number to make the proportion true. And something that will make it very easy is all you do is look at the number across. Look at the numbers that have values in both the denominator or the numerator and try to figure out, how do you get to the number across? Well, it got bigger, so if it gets bigger, I'm going to multiply. So I'm going to say, if it gets bigger, I'm going to multiply. If it gets smaller, I can think about dividing. So how do we get from 5 to 50? 5 times what equals 50? Well, 5 times 10 times 10. So 5 times 10 equals 50. So 4 times 10 equals 40. So x equals 40. 4 out of 5 is the same exact thing as saying 40 out of 50. Let's check. Let's simplify this one. Okay, well, I can divide by 10 and I get 4/5. They're the same. It's true. We need to find the missing number that will make the proportion true. Let's go to the next slide. All right. So this is just reiterating what I said on the last slide to see if there's a number. See if there's a number that could be multiplied or divided to get to the number across. Here, we said, oh, it's times 10. So times 10, so x equals 40. There we go. Make sure you show work of what you're doing. Here, whoa, okay, how do I get from 60 to 20? Okay, now I'm going to divide because it got smaller. Divide by what? 3. So 12 divided by 3 equals 4. So x equals 4. And if you wanted, you can kind of still work backwards because look, 12 out of 60 equals x over 20. Instead of going left to right, you can go right to left. Look, how do you get from 20 to 60? Times 3. Okay, so what times 3 equals 12? What times 3 equals 12? 4. So x equals 4. You get the same answer. Okay, next slide. All right, go ahead and practice these 3. Press pause after I'm done talking. Make sure you show your work, and then come back to check your work. Go ahead. All right, so from 10, I look at these ones because I have these numbers. I have both numbers in the denominator. Sometimes it could be on top. X doesn't always have to be on top. X could be at the bottom. So I'm gonna say, how do I get from this number to this number? I times 10. So times 10, x equals 40. Okay. 45 to 90, that's times 2. So 15 times 2, x equals 30. Okay, ooh, how do I get from 18 to 6? Okay, divide by 3, divide by 3, x equals 4. There we go. Okay, so when you're doing this work, this is what I'm going to highlight is the work I expect to see. What you're multiplying or dividing by and a circled answer. Okay. All right, so when you're solving these, it won't always be so easy to see the number across. And that's where the next part comes in, the complex way. Because what if it doesn't work? What if there isn't a number that you can easily multiply or divide by to get to the number across? That's where the butterfly method comes in. So we just finished solving simple proportions. Before that, we identified proportions by simplifying both fractions to see if they were equivalent. Okay. Now we're going to learn how to find missing values in situations where you can't get to the number across. 3 times something not so easy gets me to 5. That makes it complicated. So I'm going to show you another way how to solve those types of problems. So this missing variable can be anywhere. Okay, so the ones that we've seen so far is something like this, right, where the missing variable is right here. Right, there could be others where the missing variable could be down here. I'll put 3/9. All right, it could be here. So it could be in any 4 of these corners. It could be in any numerator and any denominator. Okay, so, but the rules are still the same. It works the same way. Remember, we're trying to find the variable value to make the proportion true. So again, let's look at this slide. There are 2 ways to solve this. One is if there is something you can easily see to get to the number across. But if that doesn't work, that's what this part of this video is all about. So pay close attention. All right, so if I have a problem like this, 3 out of 18 equals G out of 51, it does not always have to be X. The unknown could be any variable, any letter. All right, so if I have a problem like this, for this problem, I would say, okay, 3 times 51 equals 18 times G. So let me do that again. This is what I would do. This is also called cross multiplication. When I'm making a cross, 3 times 51, so that's what it says right here, equals 18 times G. So it's the numerator of the first ratio times the denominator of the second. So 3 times 51 set equal to the denominator of the first ratio times the numerator of the second ratio. So 18 times G. That's what you're going to be doing. So when I solve this, 51 times 3, 51 times 3, I get 3, 153. 153 equals 18 times G. It's just 18G. Huh. It just gives me a one-step equation. So divide by 18, divide by 18. G equals 153 divided by 18, which is 8.5. So what this is saying is 3 out of 18 is the same thing as 8.5 over 51. That will make this proportion true. If you need to look at it letter-wise, so it will be A over B equals G over C. So it's A times C equals B times G. No matter what those numbers are, it will follow this procedure right there. So let's go ahead and practice a couple of those problems. So, when I have a problem like this and I'm trying to solve for the missing variable, always check to see if there's a number that you can multiply or divide by to get to the number across before you do the butterfly method. So how do I get from 8 to 12? Well, I really can't. So this is where I'm going to want to do the butterfly method. So it looks just like a butterfly. 6 times 12 equals 8 times x. And if you wanted to do it the other way and say, okay, 8 times x first, because what if you like your variables on the left? equals 6 times 12. It doesn't matter. You'll still get the same answer. Because look, 12 times 6. 12 times 6 is 72. Equals 8x. Okay. 8x equals 72. Okay. Divide by 8, divide by 8. Okay, 72 divided by 8 equals 9. So x equals 9. Let's see if it works out on this side. X equals 9. There we go. So what this is saying is 6 out of 8 is the same thing as 9 out of 12. Maybe I don't really believe that. So let me simplify this and see if it's true. Okay, 3 out of 4 divided by 3 divided by 3. I get 3 out of 4. Whoa, look at that. It's true. It makes it proportional if x equals 9. Let's try this one together. Ooh, look, the x is on the numerator of the first ratio. Okay, so I'm going to say x times 10, or 10 times x, it does not matter how you write it, equals 15 times 6. Okay, so x times 10 equals 10x, and 15 times 6 equals 90. I'm going to divide by 10, divide by 10, x equals 9. Whoa. If you want to check your work, 9 out of 15 equals 6 out of 10. Okay, divide by 3, divide by 3, divide by 2. These ones have a 2 in common. So I get 3/5 equals 3/5. It's true. Remember, it's proportional if both ratios, both fractions, when you simplify both of them, if they equal the same fraction, the same exact number, even if you made it into decimals, then it's true. They're proportional. All right, go ahead and try this one on your own and then come back when you're done. Press pause and then come back. Go ahead. All right, so you should have had x times 6. So x times 6 equals 9 times 8. And that would have been 6x equals 72. Divide by 6, divide by 6, because now it's just a one-step equation. Because you're setting up an equation from the proportions. X equals 9. Oh, sorry. X equals 12. There you go. All right, try another one for practice. The next slide. All right, try that one and then come back. Press pause now. All right, so hopefully you did x times 6. You could have written 6 times x. It does not matter. And then times 9 times 16. That makes 6x equals 144. Divided by 6, divided by 6. And x equals 24. Remember what we're saying. We're saying 24 out of 9 is the same thing as 16 over 6. And if you simplify both of them, you should get the same fractions, because it would mean that they're proportional. All right, practice this one. Press pause and then come back. All right, so it'll be 15 times x equals 50 times 3. If you wanted to, you could simplify that to equal 1/5 if you really wanted to. Divide by 3 top and bottom. If you want to simplify first, that can make the problem be a bit simpler if you want. All right, so 15x, you'll get the same answer. 15x equals 150. Divide by 15, divide by 15. So 150 divided by 15 equals 10. We're saying that 10 out of 50 is the same thing as 3 out of 15. And again, if you simplify both of them, you should get the same answer. They should be the same fraction, meaning they're the same value. So divide by 10, divide by 10. So right now we're just checking our work. That makes 1/5, and then divide by 3, divide by 3. That also makes 1/5. So our answer is correct. All right, the next slide is the last problem I'm going to have you practice for the butterfly method, but the only difference is it has units. So instead of just numbers, it has units, but you solve it the same way. So it says we might have labels. Really, you may have units. Okay, labels, units, they're the same thing. So it says m minutes over 8 miles is the same thing as 24 minutes out of 3 miles. Well, automatically I can say 24 divided by 3 is 8, but let's just use the butterfly method to help us. Okay, so if it helps, you could just rewrite it. Okay, because we're trying to find minutes. That's what m is, minutes. So just do the butterfly method. 3m equals 24 times 8. Okay, so it's 3 times m. 3m equals, so 24 times 8 is 192. Divided by 3, divided by 3, and m equals 64. Wait a minute. 64 over 8 is the same thing as 24 divided by 3. Remember when I looked at this and I'm like, oh, that equals 8? 24 divided by 3 is 8. 64 divided by 8 is 8. It has the same exact value. Ding, ding, ding. All right, so we just finished solving complex proportions using the butterfly method. Before that, we were able to solve simple proportions by looking to see how we get the number across. Like to get from 3 to 6, we just times 2. So then x equals 4, because if we multiply by 2 on the bottom, we multiply by 2 on the top. So our unknown would be 2 times 2, which is 4. So x would equal 4 in that case. And then before we identified proportions, if I gave you 2 fractions, you simplified both to see what the root value was in its simplified form. If they were the same, that meant it was proportional. Now the next thing we're going to learn about is how to set up to solve proportions. All right, next slide. All right, to show you how to set up proportions, I'm going to teach you it using a graph. Okay, so this graph shows data taken from a class survey that asked students what animal they would want. Okay, there were 35 students. If I didn't give you the number 35, you can say, okay, well, this was 5, this was 15, this is 5, this is 10, so add them up. 5 plus 5 is 10, so I get 35. Okay, just in case they didn't give it to you. Okay, let me erase those. Ooh, let me press undo. Okay, there we go. I'll just erase the 5. Okay, all right, so what this is saying is that 5 students, so number of people, so students, 5 students would choose a dog, 15 students would choose a cat, 5 would choose a bird, and 10 would choose a pig. That's how we read this graph. Okay, we're going to use this graph to help us with some of these problems. Okay, so if I asked you how many people chose a cat, you will look at this one and say, oh, it goes up to 15, so 15. But what if you know that this is out of 35 students? That would be 15 out of 35 students would choose a cat. But what if I said, okay, let's think about the future. What if I want you to use this information to help us determine a population that is either larger than 35 or a population that is smaller than 35. So this slide says, what if I wanted you to find the amount of people who would choose each of those pets if the classroom had more than 35 students or if it had less than 35? How would we do that? By setting up proportions. So, in order to do that, okay, we'll need to set up a proportion. One fraction represents what you already know. So information you already know. The other one represents, will include the new number and an unknown that you are trying to find. So let's look at a separate example so that we can come back to the class survey problem later. It says 5 out of 10 people like pizza. I personally think that the percentage is more, but okay. 5 out of 10 people like pizza. Predict how many people will want pizza if there were 50 people. 50 people? I only know the data for 10 people. That's what we're trying to figure out. Okay, so I'm going to, it says one fraction represents what you already know. I know that 5 out of 10 people like pizza. So I set up what I know. I'm going to set it equal to something I don't know out of the future value. Okay, or unknown value, predicted value, it says predict. Okay, so what I'm saying is 5 out of 10 people is the same as how many out of 50? Again, 5 out of 10 people is the same as how many out of 50? The X represents how many? It's what we're trying to find. Here, if you're looking at it right now, you can say, okay, well, how do I get from 10 to 50? Times 5 times 5, so X equals 25. That's exactly what we're going to do. Or use a butterfly method if we can't find a number to multiply across. We can do that part. We know how to solve. We did that with the other parts of this video. This part is dedicated to setting up the proportion to solve. So let's go back to that graph. All right, it says how many people would want a dog if there were 100 people? Okay, well, let's see how many want a dog right now. Okay, there's 5 people who want a dog. 5 people. Set up what I know. So 5 people out of how many people? 35. Okay, 5 people out of 35 want a dog is the same as how many out of 100 people? So if I want to think in terms of units, 5 people, 5 people want the dog, right? So how many people would want the dog if there were 100 people? So try thinking of it in terms of units as well. That could help. Okay. So let me go on to number 2, because I'm not going to solve that right now. Number 2, how many people would want a pig if there are 100 people? So look at the graph and think about, how many people want a pig right now? Out of how many? And set that equal to something. Okay, what do I know? I know that 10 people would want a pig. So 10 out of 35, this is what I know, is the same as how many out of 100? Okay, so you can think of the bottom ones as your totals. Okay, as your totals. We're not going to solve these right now. We're just setting up the proportions. Go ahead and try to set up those proportions. Don't solve them, just set up the proportions. Okay, when I'm done talking, press pause and then come back so you can check your work. Go ahead, press pause. All right, it says approximately how many people would want a cat if there were only 10 people? Okay, well, there are 15 cats. So 15 out of 35, because that's the data that's given to me, is the same as, how many people would want a cat if there were only 10 people? Right now, 15 people want. Well, what if there were only 10 people? Okay, how many would want out of a total of 10 people? Use units to help you. Right? There you go. That's what it should look like. Now let's look at number 4. Approximate how many people would want a bird if there were only 10 people. Okay, well, there's 5. Okay, 5 out of 35 is the same thing as how many out of 10? There we go. So as you can see, the population decreased from 35 to 10, 35 to 10. In the previous example, the population increased from 35 to 100, 35 to 100. Okay. So again, this section is all about setting up those proportions, not necessarily how to solve them. But on the next slide, we'll set it up and solve it just so we can see what it looks like if we were to solve. Okay. Using the data from this chart, how many people would choose pizza if the population was 400 students? Okay, whoa, okay. Let's see. So I know there's 400 students, but it's asking how many would choose pizza. Okay, where's pizza? Here's pizza. 50 people would choose pizza. Okay. Well, using the data from the chart, I need to set up what I know. Right? What I know. So if I go back to, let's see, where's that slide? If I go back to this slide, it says what I know, set up what I know, set it equal to my unknown and any new number that I have. So what I know to the new stuff. Okay, so what do I know? I know 50 people out of not 400. Well, my data is right here. I should add these numbers up. Okay, 60 plus 50 plus 8. Okay, 8. So 118. Sometimes I'm going to have to add up the data. Okay, so 50 out of 118 people is the same as how many people out of 400 people? So 50 out of 118 is the same as how many out of 400? Okay, let's do our butterfly method. These are big numbers. Okay, so 50 times 400 is the same thing as 118 times x. So 50 times 400 equals 20,000 equals 118 times x. Divide by 118, divide by 118. X equals approximately, so it can't be equal, approximately, if I look at the calculator tells me x equals 169.4915254237. Ooh, we can't have that. We're going to have to round. And the answer would be approximately 169. We cannot say 169.5 people. You can't chop people in half. You can't do that, right? So you'll have to do little squiggly lines to say approximately. Approximately 169 people out of 400 would choose pizza. Okay, so if 50 out of 118 people choose pizza, then approximately 169 out of 400 will also choose pizza. Let's look at the next one. Using the data from the chart, how many people would choose hot dogs if the population was 400 students? So go ahead and press pause and then come back to check your work. All right, so let's see. How many people would choose hot dogs if the population was 400 students? Okay, so hot dogs. There's 8 hot dogs. 8 hot dogs. I'm going to put hot dogs out of a total of 118 people or students. Okay, is the same thing as, let's see, how many people would choose hot dogs if the population was 400? Okay, well, I know hot dogs are going to go on top because I have hot dogs on top. And people is going to go on bottom, which is the same thing as students because I use people and students. Really, it should just be the same word. But so that will help me determine what goes where. This says 400 students. So 400 people. So X is right there. So I should have 8 over 118 equals X over 400. Okay, that should be your proportion. If for some reason you did this instead, x over 400 is the same thing as 8 over 118, that also works. Okay. You might also see some people flip it in another way, where if they flip this one, it's the same thing as long as you flip this one. It means the same exact thing. Because 400 over x is equal to 118 over 8. So you may see these represented in different ways. It means the same thing. Okay. As long as they're placed in the correct spot. So, for example, this represented people. A cross must also represent people. If this is hot dogs, a cross must also equal hot dogs. Okay, you can't have people in one numerator and hot dogs in the next numerator. You can't mix them up. They have to be the same units across, or that means the proportion is wrong. Okay. All right, so let's go ahead and solve this one. So I'm going to say 8 times 400 equals 118 times x. So 400 times 8 is 3200 equals 118x. Divide by 118, x equals approximately, not equal, x is approximately 27. So approximately 27 people out of 400 would want hot dogs based off the ratio, based off the data that's given to me. All right, let's try another one. It says 500 teenagers were sampled at random about their favorite movie genre. The results are listed in the table below. Out of a population of 200, about how many would prefer comedy movies? Okay, well, okay. So out of a population of 200, how many will prefer comedy? Well, comedy, there's 78. So 78 comedy out of a total population. So I'll put teenagers equals something comedy over teens. So let's see. Okay, so 78 comedy out of, how many total? Oh, I'm going to have to add them all up. If I didn't read the first part, 500, so it should equal 500. So out of 500 teens, so 78 teens out of 500 is the same as how many teenagers would want comedy out of 200. There you go. So we have 78 out of 500 equals x over 200. And then you go ahead and solve. And when I do that, I do 78 times 200 equals 500 times x. Okay, so 78 times 200 equals 15,600 equals 500x divided by 500 divided by 500. X equals, it says exactly 31.2, but you can't chop people in half. You can't cut them up in pieces. So you can't use that as an answer. You have to say x equals 31. Round to the nearest whole person. Round to nearest whole person. Okay. All right, one more example I want to show you that's using proportions but not using a table or a graph is one using shapes. All right, so this question says these shapes are similar. Similar is the same thing as being proportional in a way when we're talking about shapes. It just means one may be a little bigger than the other in size, not in value, but in size. So this is what helps me solve this type of problem. What I like to do is I kind of like to color code it. So if I look at this triangle, here's the top left of the triangle. So I'm going to code this one as blue. And if you just have a pencil, which most likely you will, you can even use squiggly lines, okay, or dots. Okay, and that can help. So what I'm going to say is, so if I have this and I'm trying to compare, I'm going to first find the x. Here's the x. Okay, well, the x is right here. I shaded that as blue. So where's the blue shaded part on the other side? Right here. So I can say x over 7 is the same thing as, well, okay, let me see the 6. Oh, there's no value for this one, so I don't want to use that one. That's just an extra number that they're giving me to confuse me. So I'm going to use these ones, okay, because they're both the dotted side and they both have numbers. So I need to use that. Okay, so, but which number is going to go on top? Well, if you start off with this one as the numerator for the first ratio, this must be the numerator for the second ratio. So 6 out of 8. We're saying x over 7 is the same thing as 6 over 8. Now let's go ahead and check to see if we find that anywhere. Okay, x over 6, nope. 7 over x, nope. 7 over x, nope. 7 over x, nope. But I know I did that right. Let's see if there's another way I can write this ratio. So let me erase these, my little notations over here. All right, so here's my x and here's my 7. Well, what if I wanted to do this one first? I'll put 7 over x, make a ratio with those sides. They're actually called corresponding sides where they're in the same spot, corresponding. Okay, so 7 over x, and then I'm going to look at these two again, but I'm going to put this one first. 8 over 6. Okay, let's see if I find that anywhere. 7 over x, nope. 7 over x, I see it right here, equals 6 over 6. No, it can't be 6 over 6. Can't work anyways. Okay, 7 over x and 6 out of 8. No, those are flipped, so that's not going to work. Okay, 7 over x and 8 over 6. Whoa, that looks pretty accurate to this one, except that they're on the other side of each other. That's okay. It still means the same thing. 7 over x is the same thing as 8 over 6. 8 over 6 is the same thing as 7 over x. So that one matches. That matches. Okay? It's the same thing. It doesn't matter how you write it. One other thing, what if you didn't see this one either? All right, what if you didn't see this one here? Well, something that other people do is they flip this one and they say, okay, x over 7. If they flip 1, they have to flip the other fraction. Oh, look, it looks similar to the one I originally had. And that's okay. As long as you flip one side, you have to flip the other. Okay, so it's like when you're solving an equation. If you add 1 to one side, you have to add 1 to the other side. If you flip one side, you need to flip everything else on the other side too. So it makes sense. So this is how you do a problem with the shape, right? Try coding it. Code each side, each corresponding sides, the sides that match. Like I did a little squiggly line to represent, this one represented the right side of the triangle, right side of the triangle. Here I used dots to represent the bottom, And I did, I put a color here. So if you want, you can make one like a thick side and then use that to help you. Look for the X and then use that to make your ratio. All right, so we set up proportions and solve them. Now we're gonna look at some percentage problems using proportions, and then we'll finish up by looking at scales. So part 5, setting up and solving percentage problems. All right, what if I give you percentages and I say something like 70% of people in the United States like apples? How many people out of 200 people will like apples? It's the same kind of thing of what we've been doing, except that it's a percent. And percents are always out of 100. So whatever the percent is, say 70 out of 100 is the same thing as how many people out of 200. So let me show you again. Any percent it is, It says 70%. Always put the percent over 100. Always. Always put it over 100. Okay, so 70 out of 100 people is the same thing as how many out of 200? This is how we can do it using proportions. Then you can use, look, if I look at what it's across, times 2 times 2. So 70 times 2, that's going to be 140. So x equals 140. Okay, that was pretty simple. Or use the butterfly method if you can. Okay, there's actually another way, obviously, that you can solve this without using proportions. 70% as a decimal is 0.70. So multiply that by 200. And if you multiply that correctly, you get 140. So there's lots of other ways you can solve these kind of problems, but the point is to show you how to use percentages with proportions, setting up those two ratios and setting them equal to each other. So you can use this to check your work right here. Okay, convert the percent to a decimal, percent to a decimal, find the decimal, move it 2 times to the left, and you get 0.70. It's the same thing as 0.7. Okay, and then multiply it by the quantity. But we want you to use proportions. So let's look at the next slide. It says below is a graph of how many hours people walk their dogs a week. Predict how many people out of 3,000 would spend 2 hours walking their dogs a week. Okay, where's the 2 hours? Here's the 2 hours. That's 20%. Ooh, percent's always over 100. 20 over 100 is the same thing as, says how many people out of 3,000. And then you can do your butterfly method or multiply to see what you can get across. So always check to see if you can multiply something first before you use a butterfly method to make it easier. Okay, so if you multiply by 30 times 30, x equals, so 20 times 30 equals 600. So if 20% of people walk their dogs for 2 hours a week, then that means out of 3,000 people, if there were 3,000 people, that's 600 people. Okay, let's try the next one. Go ahead and see if you can do this one on your own using the same method we did on the previous slide. Press pause and then come back to check. Go ahead. All right, so below is a graph of how many hours people walk their dogs a week. Predict how many people out of 3,000, 3,000 again, would spend 4 hours walking their dogs a week. Okay, 4 hours. Here's 4 hours. 15 out of 100 automatically, because it's a percent. Percents are always out of 100. Is the same thing as how many out of 3,000. Okay, out of 3,000. So if I were to do my butterfly method, 15 times 3,000 equals 100 times x. Okay, so 15 times 3,000 equals 45,000 equals 100x divided by 100 divided by 100. What's nice about zeros is you can cancel those out. So x equals 450. So 15%, we're saying what's 15% of 3,000? 450. Because this is percent. Okay, so 15 out of 100 is the same thing, because 15 out of 100 is 15%. 15 out of 100 is the same thing as 450 out of 3,000 people. All right, the next slide is the last slide we have for this part of the lesson. So it says the table below shows the percentages of automobile sales for various makes of cars. If a total of 3,500 cars were sold, how many cars of brand B were sold? So I'm going to go ahead and let you try this one on your own. If you want, try both ways, where you're setting up a proportion, and another way where you're converting the percent into a decimal and then multiplying, and see what you get. See if you can figure both out. Okay, Go ahead and press pause and then come back. All right, so I'm going to show you both ways, just in case. Okay, so I'll make one smaller. All right, so the first way we would say brand B, 28. So 28 out of 100 is the same thing as how many out of 3,500. Okay, then we got to do our butterfly method. So 28 times 3,500 is the same thing as 100x. So 28 times 3,500 equals 98,000 equals 100x divided by 100 divided by 100. Cancel, cancel. So x equals 980. So here we go. So this is the way that I for sure want you to be able to do. Another way that you can also use it to check your work. But this is the way I'm going to want you to do it when you're doing your homework. You can say, okay, 28% is 0.28. So 3,500 times 0.28. When you do that, you get 3,500 times 0.28. Right, you're going to get the same answer in the end, 9,800. You're probably going to get this once you do all your work. Then you have to make 2 jumps to the left because there's 2 numbers behind the decimal. So you get 980. You get the same answer. All right, now we are on to the last part, scales using proportions. So here's an example of a scaled problem. All right, what's going to happen is I'm going to give you a picture. All right, and it's a miniature version of something. And I'm going to actually give you the real length of one of those measurements. And you're going to create a proportion to find out the real length of what's missing. So for example, I have this building right here. It says the actual width of the building shown in the model below is 60 feet. Width is how wide it is. It really is 60 feet, it's saying. But in this picture, it's saying 2 centimeters. It says, what is the actual height of the building shown in the model? Well, I'm just going to set up a ratio of what I have. Okay, so this is my width and this is my height. My width is how wide it is. My height is how tall it is. So I'm going to say, okay, 2 out of 5. 2 is my width. 5 is my height. It will be a very good idea to label these. You can get lost very easily. Okay, it's the same thing as something else. So width and height. Remember, whatever unit is on top should be the same unit across. So if it's width on top, it should be width on top for the second numerator. If it's height on bottom for the first denominator, then it should be height on bottom for the second denominator. They should match across. All right, so let's see. The actual width of the building is 60 feet. Okay, so that goes here because it's width. Remember, width is on top. We set it up that way. Then that means that X is on the bottom because we don't know the actual height, because that's what it's saying. What is the actual height of the building? Okay. All right, so now we can use our butterfly method. So let me rewrite it. 2 out of 5 is the same thing as 60 over X. Okay, 2 times X is the same thing, well, equals 5 times 60. Okay, 2X equals 60 times 5, which is 300, divided by 2, X equals 150. Right there. And it's okay that there are different units, that one is in centimeters and the other ratio is in feet. That's okay, because we're comparing something that's similar. Let's try another one. A model drawing of a house is shown below. Okay, automatically I know this is the width and this is the height. If the actual house is 20 feet tall, ooh, how wide is it? Okay, let me set a proportion up. All right, so I'm going to put width on top. So width and the height on bottom equals something width and then height on bottom. If you wanted, you can reverse that and put height on top, width on bottom. You'll get the same answer in the end. Okay, so let me see. So my width was 25 and then 27 and a half. Okay, my width of the actual house, we don't know, so that's x because it's saying how wide is it. But the height, how tall it is 20. So right now I have 25 over 27.5 equals x over 20. So we're just going to use a butterfly method and solve that. So 25 times 20 is the same thing as 27.5 times x. Remember, this is a decimal, it's at the bottom. Multiplication's in the middle. Okay, so 25 times 20 is 500 equals 27.5 times 5 equal, oops, sorry, why am I saying times 5? I'm getting confused in my dots. So this may be a good idea for if it's like that, maybe you might want to use parentheses to show that it's multiplication. Okay, so then I have 27.5 times x divided by 27.5 divided by 27.5. Okay, so x equals 500 divided by 27.5, which is approximately 18.18. It's repeating right there. Okay. Well, what if I did it the other way? What if I wanted to have height on top and width on bottom? Let's see what would happen then. Because we should get the same exact answer no matter what. It should be. Okay, so my height would be 27.5 over 25. My height would be 20, and we don't know the width. So look, 27.5x equals 25 times 20. This part looks exactly like this part. They're the same. So no matter what, you'll get the same answer in the end. Okay, you do all your work. So it'll be 27.5 times x equals 500 divided by 27.5 divided by 27.5. X equals 18.18 repeating, and you get the same answer. Okay, so again, people can set up the proportions however they want, as long as they have the same units on top and the same units on bottom. Okay, so I want you to try this one on your own and then go ahead and come back when you're done to check your work. Go ahead. All right, so it says the catalog sketch of this TV is drawn to scale. Okay. If the actual height of the TV is 54 inches, so the actual height equals 54, then what is the actual length of the TV? Okay, so right now, length is how long it is. It's like the width. So here, I'm just going to say length. You can make it W if you want. That's supposed to be an L, cursive L. And then this is how tall it is, so that's my height. So I'm going to just put my lengths on top and my heights on bottom. You can do the heights on top if you want and lengths on bottom. It's up to you. Okay, so what do I know? My length is 7 and my height is 6. And then my actual height is 54. I don't know my length. That's where my x is. So really it's 7 over 6 equals x over 54. Okay, so now I'm going to want to do my butterfly method. Okay, unless you can directly see that you can multiply across, which you can. Okay, and in this case, if you can multiply across, then that's all you need to do. Look, 6 times 9 equals 54, so 7 times 9. 7 times 9 is 63, so x should equal 63. If you can see that automatically, then there you go. There's your answer. That's all the work you need to show. But what if you didn't see that and you need to use the butterfly method? Okay, so then 7 times 54 equals 6 times x. Okay, so 7 times 54 equals 378 equals 6x. Okay, so 378. We're going to divide by 6. So x equals 63. Okay, you get the same answer. So always check to see, once you set up your proportion, can you multiply to get to number cross? If you can, go ahead and multiply or divide. If you can multiply or divide, do it. But if not, then you need to use the butterfly method. So butterfly method. All right, last problem. Scales. Let's look at this one. The model of the car below uses a scale of 1 centimeters equals 3.5 feet. Okay. The length of the whole car is 3 centimeters. What is the actual length of the car in feet? In feet. So go ahead and press pause and see if you can figure out this, and then come back if you get stuck. Go ahead. All right, there's actually multiple ways you can do this problem. All right, but let me show you using the butterfly method. So we know that 1 centimeter equals 3.5 feet. Okay, so I'm going to leave centimeters on top and put feet at the bottom. All right, I have 3 centimeters, but I don't know the feet. So I'm going to have 1 over 3.5 equals 3 over x. So I'm going to say 1 times x equals 3.5 times 3. So 1 times x is x, just x. And 3.5 times 3 is 10.5. That matches this one. Well, there's something else you could have done too. You could have just done 3 times 3.5 because each centimeters equals 3.5 feet because that's 1 centimeter, 1 centimeter, 1 centimeter. So 3.5 plus 3.5 plus 3.5 is the same thing as 3 times 3.5, which is 10.5. Okay, so you could have done it another way if you had wanted. And it makes sense because look, you're multiplying 3.5 times 3 anyways by setting up a proportion. So it works. So the first thing we did was identify proportions. I gave you 2 fractions. You had to simplify them to see if they equaled in value, if they were equivalent in its simplest form. Putting it in its simplest form makes it easier to identify. Then we solved simple proportions by you had a missing value and you had to see if you can multiply or divide by something to get to the number across. And then we had some proportions where you couldn't multiply or divide easily, so you had to use a butterfly method. Then we learned how to set up some proportions to solve. Then we set up proportions to solve percentage problems. And then we use proportions for scales. Okay. All right, that's the end of the lesson. Thank you so much to the interpreter who helped us, or interpreters for helping us create this full lesson video. Thank you so much.